Hello my dear students, welcome back to the channel. Today I'm here with another new chapter, the rapid revision of continuity and differentiability. It is an interesting chapter, don't you say? It's going to be one of the high weightage coming in your PU2 midterm, so we have to be very careful while learning and revising the concept of continuity and differentiability. All of you agree? Yes. So we're going to cover each and every concept. It has to be rapid because that's what the session is. Rapid revision of all the concepts in this chapter, and of course later on you'll have 1 marker questions that you're going to solve. Don't just watch the video, please solve the questions at the same time. And later on you'll have a session where we're going to solve 2 marker, 3 marker, 4 marker, 5 marker, all the categories. So I saw some comments that, sir, is this question enough for this chapter? Certainly bacha, I'm telling you, whatever questions I'm picking are one of the best, okay, and I'm gonna solve all of them for you. So please make sure that you solve all these questions, and do not worry, I'll be with you. We'll come up with more and more problems for every chapter. We'll do more marathons, we'll do complete revision, complete solution of all the problems in these chapters of your PU2 midterm. So trust me when I say, if you follow our content properly 100%, you'll gonna get very good marks in your midterm examination. Is that clear? Okay, so if you are ready for that, let's start the session. As I said, it's a very rapid revision, so we'll have to be very much in the flow. Let's start. So first thing is going to be what? Today's session we have a lot of things coming up. We'll complete all the subtopics. First thing, yes, the question from this topic comes either in 2 marker, 4 marker, very rarely, but yeah, sometime in 1 marker category also. So yes, so this is going to be on the definition of continuity. So how do you define continuity? So how do you define, or when can you say a given function is continuous? Very simple, sir. We have learned that you just find the limit of a function, okay, and if it is equal to the function value, it is continuous. And you're exactly right, okay. So you try to find limit, okay, limit value you're gonna find of the function. Let's say the point is x tends to a. You're gonna find this value, and this will be equal to f of a. Whenever you have that, whenever you have this statement true, then you can say the given function is continuous in nature. Now how do you find limit? Of course, we have learned that in our PU1 we use the LHL and RHL approach. Sometimes it's not required, we directly take the limit x tends to a, but yeah, we use LHL and RHL approach. What is LHL RHL approach? It means we try to move to a from the left hand side, x tends to a minus, and for RHL we use what? X tends to a plus. For all of you who are still wondering how do we approach this, how do we solve actual questions on this, do not worry, I'm here, right? When I take the questions in 2 marker, 3 marker, 1 marker, I'll explain you the applications of these as well, okay? But for now, just the concept part, definition of continuity is if you have the limit equal to the function value, that's the case of continuous function. It implies what? That fx is continuous at x equals to a. At x equals to a. It means when the LHL RHL are equal and they're equal to the function value at a, this whole thing means that the given function is continuous. Is that clear? Okay. The point where the function is continuous is called as, of course, point of continuity. Very simple. The thing is, we'll not try to complicate the concepts. We'll try to learn and summarize in the simplest way possible. That's our goal in this session of rapid revision, continuity and differentiability. Let's continue now. Yes, next up, when can we say, yes, we learned the definition of continuity, but when can we say the given function is discontinuous? So sir, whenever it is not continuous, it is basically discontinuous. Correct, that is true, but I'm gonna give you 3 simple summaries. If you remember those, it'll help you understand and reach to the conclusion faster. There's no other way, okay? Of course, your way is right. If it is not continuous, means it is discontinuous. Let's see, first of all, whenever, what is this called as, sir? We just learned this is LHL, and what is this part called? RHL, okay? Whenever both of these, okay, are, when you're trying to find out, may not exist, mean, let's say, either of these, either LHL or RHL is not going to be, existing in nature. You can't find the value for that, okay? It's coming as undefined or whatever it is, okay? Whenever either of these two does not exist, then you're gonna say what? The function is not continuous at the point x equals to a. So basically discontinuous. Moving on, if you have both existing in nature but not equal, what this 2 point implies? Basically limit does not exist. Limit both the point 1 and 2 implies that limit does not exist, because for the limit to exist, if you remember PU1, how can we say the limit exists? Both LHS and RHS should be existing in nature and equal. First option was does not exist, means limit does not exist. Option 2 was both exist but not equal, it means limit does not exist. Okay, third one, both exist, both LHL and RHL exist and they're equal also but not equal to the function value at a. The function value at a means limit is actually existing in nature but the limit value is not equal to function value. Then again the point A will become what? Point of discontinuity. It will become point of discontinuity. Is it clear? Is it clear now? So 3 ways. First 2 ways, when limit does not exist, of course, then clearly the function is discontinuous, and the last is limit exists but not equal to function value at a. So basically, if a function is continuous, it means what? Limit exists and it has to be equal to function value also. Either of them cannot be true, both at the same time. Limit should exist and should be equal to function value, then only you can say it is a continuous function at that point. Okay, let's move on. Next we have something very interesting. Once I start solving questions, no, I have taken a couple of questions in this. I'll show you. I'll remind you there कि yes, this is a concept based upon algebra of continuity. I think name makes it very simple. We'll talk about continuous function and we'll see their algebra. What is the meaning of algebra? Their summation, their difference, their product and their ratios. Yes. So for that we have to assume one thing, that function f and g are two functions which is again real, okay, and continuous at the point x equals to a. So both the functions are real functions and they are both continuous at the point x equals to a. When that is true, what do we have? Our first algebra states f plus g will also be continuous. Will be continuous. Second algebra is what? F minus g again will be continuous. Third is f into product will also be continuous, and the last is f by g will also be continuous provided g of a is non-zero in nature. Provided g of a, because it's a denominator, right, it cannot be equal to 0. So f plus g will be continuous, f minus g will be continuous, and f into g will also be continuous in nature, and so is the ratio f by g. This is the 4 points that is involved in continuity of algebra. Okay, sorry, algebra of continuity, my bad. Now over here you see the note. It's important because it's for the composite function. It talks about fog. It talks about fog. Okay, check. So for this, no, if you are looking for a fog to be continuous, the necessary condition is g of a should be continuous. Basically g should be continuous at a. Check here, g should be continuous at x equals to a. That's the first requirement. Next is f, because f is operating on g, right? So f should be continuous at g of a. If you have that, if g is continuous at the point a and f is continuous at the point g of a, then you can call fog is continuous at the point x equals to a, basically using the composite functions condition. Okay, definition. Let's move on then. Another very important concept where we talk about interval sense. Okay, this plays a big role when you get to AOD. Okay, increasing decreasing function, the interval is involved there, right? So when you solve the questions on that, continuity of an interval, solving questions on interval plays a big role. Let's understand this right now. What is there for the continuity and differentiability part. Okay, so continuity in an interval means what? It means very simply that every single point, continuity means what? That at a point it should be what? Limit equal to the function value. So in an interval, whatever is the number of point, it should be the same condition, right? Because interval is what? Interval is a family of points. It will have lot of infinite number of points. It will have, if I write here interval 2 to 3, what it means? It means I have infinite number of points between the value 2 and 3. That's what this interval means. Okay, and continuity at a point, we know for every point function value should be equal to the limit value. So in this interval, what it means? How do you define continuity in this interval? Very simple. For all the points, the function should be continuous. Okay, please check continuity of a function in an open interval. Why open? Because we have two types of interval, no? So we'll learn both of them, open interval and closed interval. So we'll learn both of these. Let's learn the first part, which is open interval. A function fx is said to be continuous in an open interval a comma b if it is continuous at every point in interval. And how do you define the continuity at every point? Function value equal to the limit value, right? So that's what it is about open interval. Now for closed interval, we have to learn in 3 points. For closed interval, there has to be 3 prerequisites. Okay, means for us to say that okay, this given function is defined, it is continuous in a closed interval a to b. Closed interval a to b. For this we have 3 requirements. Requirement number 1, first requirement is should be continuous in the open interval. What's the meaning of closed interval? So closed interval will be this, sir. A and b will be both inclusive in nature. So first you should take open a to open b. That is a must. That's what it means. Continuous on the open interval a to b. First requirement. Okay. Second requirement is C. At the point A, can you find left hand limit? Can you find left hand limit at the point A? Answer is no, you can't find that. Okay, but you can find right hand limit. So at the point A, your RHL, what is this? This is your RHL. At the point A, RHL should be equal to the function value. And at the point B, you have to find what? LHL. So this is what? Please check. This is my LHL. So at the point A, the RHL should be equal to the function value, so the f of A. And at the point B, LHL should be equal to the function value, which is f of B. Okay, so these are the 3 requisites. If you have all 3 fulfilled, then you can say what? The given function is continuous in the closed interval of a comma b. First is what? Repeat after me. If you are watching this video right now, repeat after me. First is for us to say the given function is continuous in closed interval AB, first is it has to be continuous in open interval AB. At the point A, the right hand limit should be equal to function value at A, which is f of A, and at the point B, the left hand limit should be equal to the function value at point B. Okay, so this is the continuity in the interval. Now we are gonna discuss our knowledge hub as well. Okay, 4 points. Let's discuss one by one. Function fx is said to be continuous if it is continuous in each point of domain. Basically, bacha, these are simple information that you already know, but it's very important to list it down. Okay, next one, a function which is continuous at entire real line. Okay, from where to where? Negative infinity to positive infinity is said to be continuous everywhere, of course, because entire real line, right? So continuous everywhere. Next up, the function fx is said to be discontinuous on an interval if it is discontinuous at even one point, at even single point. Okay, so in that interval it has to be continuous everywhere for it to be called continuous function. For it to be called discontinuous, even one point of discontinuity will give me discontinuous function. Next up, the last point, the set of all the points at which the function is continuous is said to be its domain of continuity. Domain of continuity. Very simple statement, nothing difficult. Okay, I'll remove the markings over here. All right, So this is it in the knowledge hub for the continuity. Let's move on. Next up is going to be, as we learned the definition of continuity, we'll again learn over here the definition of differentiability. Again, very, very, very important. Okay. So in here, in the previous case, you were dealing with limits, you were dealing with LHL, RHL. Here you will deal with something called as LHD and RHD, left hand derivative and right hand derivative. Correct. Okay. Now this over here you see is called as derivative from the first principle. Okay. Again, here also there is a limit involved, and that limit is called as your first principle derivative. Okay. And you represent it like this: f dash of c dfc, or d of fx by dx at x equals to c. This is the way to represent your derivative. Okay. So whenever you have this value, at that point existing finitely, it means what? Means there should be a fixed value of that. Okay. Any finite value of that, then only you can call the given function is differentiable or derivable at the given point x equals to c. Okay. So basically your LHD and RHD should be existing and equal to each other. So there are different ways to find LHD, RHD. We use this first principle only to understand that. Let's check. So LHD, RHD. Let's go with LHD first. So what you do in this case? No, simply you write here f of a minus h. In this case, you're dealing with c, right? I wrote there the point c, no? So let me write that as c only. Let me write this as point c only. So f of c minus h minus f of c upon c minus h minus c. So this will go on, okay, and you'll have limit h tends to 0. So this will become what? F of c minus h minus f of c divided by minus h, and this is your limit h tends to 0. This represents your LHD, bacha. This represents your LHD. Looks difficult? Do not worry. Okay, actually when the question comes, this will not be difficult. Okay, I'll tell you what. Most of the time we don't use this limit condition usually. We simply differentiate function on both LHD and RHD side. Basically, we'll have two branches of the function, left hand side of the function, right hand side of the function, and we differentiate that to get result. Do not worry, when I go to the questions, I'll solve in that fashion, I'll show it to you. That is faster, that's why I'm telling you, okay? And that is correct as well. Not only just faster, that's the correct approach as well. You can use either of them. That is faster, that's why we use more often that part, okay? This is the way to use the LHD from the first principle. Let's see the RHD as well. So for RHD, what we have? Same thing. Limit c plus h will have this time minus f of c, and we'll write here c plus h minus c, where h tends to 0. This, of course, you know this, c plus h minus f of c divided by h you'll have over here, and limit s tends to 0. Now this is your RHD. Okay, this is your RHD. Now I'll give you an example where we use the other method. Okay, basically if I take this function, a special case, check, this function is fx equals to mod of x. So in this case, if I'm looking to differentiate, check for differentiability at the point x tends to 0. Okay, then we can draw the graph here, no? Very simply, check this out. The graph of modulus function looks like this. This is my y equal to x part on this side, and y equal to minus x part is this side. This is the graph of y equal to mod x, right? Y equal to x on the right hand side and y equal to minus x on the left hand side. Basically this can be written like this. I'll show you. Y equals to x when x is greater than equal to 0, and for x less than 0, okay, we have this is minus x. Okay, so if you're looking for differentiability, no, differentiate it, you're gonna get what? This x will become 1 and this x will become minus 1. Check carefully for x more than 0 and for x less than 0. So your RHD is 1, your RHD is 1, and your LHD is minus 1. Check here, your RHD equals to 1 and your LHD equals to minus 1, and we can clearly see from here RHD is not equal to LHD. RHD is not equal to LHD. What it means here is simply the function is non-differentiable at this point. The function is non-differentiable. Even though it's a continuous function, it is non-differentiable at the point x equals to 0. Okay, so this is the algebraic approach. Graphical approach will be very simple. If you can find a sharp corner in the graph, sharp corner or edge in the graph, then you can say that at that particular point the function is non-differentiable. The function is non-differentiable. So this is what you can see here. So we didn't actually use this limit wala approach to find LHD RHD. Directly we defined the function. We found the derivative of x as 1, this as -1, and that other part of the top part becomes RHD. This becomes LHD, and they are not equal. They are not equal. So usually in the questions we end up using this approach than this approach. But yeah, both approach are very important. Okay, you have to know both, because when the question comes on the differentiability, then you have to know the approach. Okay, so I hope this is clear. Both the methods of finding or checking for differentiability is clear or not? Yes. Okay, now you can let me know. Basically this is my method number 1 to find LHD origin. This is my method number 2. Let me know in the comment section which one you find better. Is method 1 suitable for you or method 2 suitable for you? Please check. Is it clear? Okay, so LHD RHD should be clear now. Very important here, very important. I've seen a question where they give you 2 variables, and to make equations you have to use one's continuity and one's differentiability. So in that you need to know this concept. Okay, you can use either of the approach, but you have to know the concept of LHD and RHD. Alright, let's move on. Next in the knowledge hub. Now this is very obvious one. So first of all, you understood right from the graphical approach. If you can find in the curve that there is a sharp corner, basically sometimes like this. Let's say you have graph coming like this, and then it is a graph like this. Is it continuous? Is the given function continuous? Yes, the given function is continuous. Is it differentiable? No. Is it differentiable? No. Okay, so basically continuity we check for whether there is a break in the function or not. Differentiability we check from the graph whether there is a edge corner in the function graph or not. Okay, now this is understanding in the knowledge hub. If a given function is basically discontinuous, a given function is discontinuous, okay, at the point they're asking us, then at that point it will be non-differentiable also. If a given function is not continuous, it will never be differentiable. It will never be differentiable. Check here. If function is differentiable, okay, let's forget about that. Yeah, I'm talking about this point. If a function is discontinuous, then it is not differentiable at that point. That's the one understanding. Okay. If it is discontinuous means it will be non-differentiable. Okay. If function is differentiable, then it may or may not be. Okay, sorry. If it is differentiable, then it will be always continuous. If it is differentiable, then it will be always continuous. Check here. For example, if I take a graph like this, I take a graph like this. Is it having a sharp corner? No. Is it differentiable? Yes. Is it continuous? Yes. So a differentiable function will always be continuous. A differentiable function is always continuous. Okay, whereas a discontinuous function will never be differentiable, and other two will be may or may not be. Function is not differentiable, then it may or may not be continuous. A function is continuous, then it may or may not be differentiable. So first and fourth point is highly important. First point is if it is differentiable, then always continuous. Fourth point is if it is discontinuous, then never differentiable. Okay, so first and fourth point are the important ones, and the third point is may or may not case. You have to check to know that. Okay, so question number the K hub is clear, the graphical part is clear. Okay, let's move on then. Now we are moving to differentiability in an interval. Again, here we'll talk about LHD and RHD. Okay, so at every point in the interval, what will happen in interval? In an interval, sir, you'll have multiple points, you'll have infinite points. So at every point in that interval, you should have what? You should have that LHD should be equal to RHD. Please check. Differentiable from both sides at every point between the A and B. Between A and B at every point. What's the meaning of differentiable? It means this point means this LHD should be equal to RHD. And what about this So since the interval is a comma b, right, you should have at the point A, this closed interval, okay, at the point A, please check, at the point A you'll have what type of derivative? You'll have RHD. You'll have RHD. What is this? RHD. And at the point B you'll have what? Left. You'll have LHD. Please check. At the point B you'll have left hand derivative. At the point A you'll have right hand derivative. Should be existing in nature and it should be finite also. It should have finite existence. Okay. So at the point A should be RHD should exist finitely, and at the point B the LHD should exist finitely. Okay, please check. All right. Next, some general theorems of differentiation. So from here onwards, your derivative, your differentiation formulas and everything starts. Some basic concepts before we move on to product rule is, if you differentiate a constant, okay, if you differentiate a constant, forgive me, then what happens? Always 0. For example, log of 2, sine 30, okay. What happens now, usually when we think of constant numbers, we say 2, 5, 15 like that. No, sine 30 is also a constant, okay. Log 15 is also a constant. So whenever you have those constant under differentiation, answer is always 0. If you have cfx, if you have a constant multiplied to the function, that can be taken outside the derivative, outside the derivative. Next up is your product rule. Next up is your product rule. Please check. If you have two functions given in the product like this, fx into gx, what you can do is differentiate one of the function, keep the other function as it is, and differentiate the function which is not differentiated in the first term. See, I differentiated gx over here, fx kept as it is. In this case, we're going to differentiate fx and gx kept as it is and take the sum. Again, in the case of product rule, there is no preference. In the case of product rule, there is no preference. But when it comes to quotient rule, you have to give preference to the numerator. Okay. In product rule, there is no preference. As I said, you can take here fx also, you can take here gx also, no problem. Okay. Now we have three functions, fx, gx and bx. You can take either of them. See here, over here we have done for fx, kept other two as it is. Here we have done for derivative of gx, kept other two as it is, and same here, differentiation of bx, other two as it is. So basically one function at a time you have to differentiate, keeping other two as coefficient. Is it clear? Please check. Okay, this is it about the product rule. Let's move on. Next is quotient rule. As I said, in this case we'll have a preference over here. What's the preference? You got to differentiate fx first. You got to differentiate fx first. Please check. This is f of x derivative first, gx is kept as it is, fx derivative first, gx is kept as it is. Then comes a minus sign. In case of quotient rule, there's a minus sign. In case of product, there was a plus sign. Please check. There was a plus sign. Here plus, here plus. Okay. But in case of quotient rule, we have a minus sign. And of course, preference given to fx. Differentiate fx, keep gx as it is. Minus sign comes. This time you're going to differentiate gx, keep fx as it is, and divide by the square of denominator, square of g. So gx the whole square. That's the quotient rule. Of course, you all know that, but I have to help you revise this as well. That's why I've taken over here. Now, one of the most important rule of derivative is chain rule. Okay, plays a big role in composite functions, plays a big role in parametric form also. Okay, so please pay attention. Whenever you have a function given in terms of another variable u, and you are asked to differentiate dy by dx, you got to differentiate dy by du first and then du by dx. For example, let's say you have sine u, you want to find dy by dx. What is the answer going to be? It's going to become sine u du by dx, sorry, cos u du by dx, right? And let me take an example over here. If I have, let's say, sine sine u, I have derivative of this will be what? This is my y. I'm looking for dy by dx. It'll be what? It'll be cos u du by dx. This is chain rule. This is chain rule. Okay, check here. Basically, your first variable should be same and the last should be same as what you have over here. Y here, x here, rest all can keep going like this. U, v, we can continue like this. Okay, we can continue like this. Okay, dy by du, du by dv, dv by dx, and so on and so on. This is the chain rule. Don't worry, when we solve the questions you'll understand this very easily if you're not able to write now. Is it clear? Chain rule is clear. Okay, let's move on then. All right, what we have next, some formulas for differentiation, and this is on ITF, sine inverse. Over here we have first 4 as the most important ones. Yeah, sine inverse is 1 upon root of 1 minus x square, cos inverse is same with the minus sign, and tan inverse is 1 upon 1 plus x square, cot inverse is same with the minus sign. Please check guys, it's written on the screen. Download the class notes. I hope you have all joined the WhatsApp channel. If you're new to the our YouTube channel, please join the WhatsApp channel right away to get all the updates of the classes and also the class notes. Okay, so we have a WhatsApp channel with the name same, Diksha Karnataka. You join right now. The link for that is given in this video's description, in the video's description. Go ahead, download, join from that link and download all the class notes in the PDF format. Okay, so somebody was asking me about PDF as well, so this is the information for all of you. Cot inverse again, minus 1 upon 1 plus x square, sec inverse of x, cosec inverse of x, again there's a formula like that. Okay, minus 1 upon x times of x square minus 1, but rarely used. The last two is rarely used but still good to know. Okay, now I'll give you some basic formula of some standard functions. For example, the first one, if I have to find out y equals to a x power n is given, ax n is given, I'm looking for derivative. We write derivative like this, y dash is the form of derivative, y dash or dy by dx. A constant will be kept as it is, this n will come in front, so n, okay, x power n minus 1. So that my answer is a n x power n minus 1 is the derivative of polynomial function. Okay, number 2, when we have exponential function involved, e power x we have, the answer becomes what? Same thing. So your answer will be e power x c is same as y dash. So derivative of e power x is same as e power x, no change. If I have, of course, let's say y equal to e power ax, then derivative is changed to e power ax times a. How come, sir? Chain rule. If you differentiate x, you get the answer as 1. That's why we have not written here e power x into 1. But if you differentiate e power ax, answer comes as e power ax, but differentiating ax will give me answer as a. Chain rule. Okay, so this is going to be a times of e power ax. Alright, next up, y equals to what we have. If I have a power x, what is the answer for this? A power x, again ln a. If you have the base as natural base e, then you have answer as e power ax, but if you have a power x, answer is a power x ln a. Okay, all right, let's move on then. If we have y equals to ln x, what is the answer? Answer is 1 by x, 1 by x. Fifth one, if I have y, sorry, this is not, this is derivative actually, my bad. This again is dot derivative actually, my bad. Okay, y equals to sin x if I have, then y dash is given by cos x. Okay, and if you have sixth one as y equals to, what is it, cos x if I have, derivative y dash is given by minus sin x. Okay, and if seventh one, if I have y equals to tan x, then y dash is given by sec square x. If I have y equals to sec x, y dash is given by sec x tan x. Okay, and if I have y equals to cosec x, then y dash is given by, what is it, minus cosec x and cot x. Okay, minus cosec x and cot x. And the last one I think missed, y equals to, if I have cot of x, then y dash is given by minus cosec square x. Okay guys, so I have listed down the formulas, which is very important, very basic formulas of different functions. Okay, so please go through this, and for more formulas you can check your NCERT. In the summary they have given all the formulas, which is important for your syllabus. Okay, so let's continue from here. I think this is okay. Have a look. Yeah, let's continue. Okay, next is basic properties of logarithms. Now some of you might want to ask, sir, why do we need this? Why do we need this? Two type of questions are there. One is where the most of the number of questions comes. Basically it's implicit function, when the function is not given directly. So usually what happens, you get y equal to sine of something like that, sine, let's say twice of x. Okay, can you differentiate this? Of course, this is very simple to differentiate, but some of the cases you'll not have function clearly written over here. You'll have x square plus y x plus y cube equals to something, let's say 10 is given here. Now they're asking you to find the derivative in this case. How do you find that? So this is the case where the subject y is not given clearly. So this is called as implicit function. This is called as implicit function. So this is one of the case where a lot of questions comes. And next case is the case of differentiation with logarithms, with logs. So in this case there are some general forms of problems where the function is given like this, fx into gx. One of the form is this, or they can give you a function like this, fx power gx, fx power gx. So fx into gx, fx power gx. Likewise the functions are given to you. Sometimes they can also give you in quotient form, fx by gx also might be given to you. So whenever you have these type of forms given, you have to apply log on both sides. Basically they'll give you like this, no, y equal to fx into gx. So you're going to apply log on both sides, okay, and then solve using the properties of log first. Okay, so what are the properties? Whenever you have in product, you can separate this as log m plus log n. Okay, again this is important, m is more than 0, n has to be again positive. This is the definition of log, right? Base has to be not equal to 1 and positive again. Okay, this is going to be the change of base. You have a and x over here, you can write e and e, you can keep going like this. Okay, next this is quotient rule. Log m by n is nothing but log m minus log n with the base same as a. Log m and a is here over here. Excuse me, I think there was a n over here. This n comes in front as coefficient, so n log a with again n log m with the base a again. Okay, and e power log e x is what? Simply x. We have one more property I want to list over here, which is very useful at times. Whenever you have log of m and a power, let's say I have what is it, b is there, a power b is there, this becomes 1 by b log of m with the base a. So usually in the board style question this doesn't come, but even if it is, let's say sometime if they're asking you, you should know the property. So if the powers of the number is there, see, if the m power n was there, then this value will come as the coefficient in the numerator. Okay, whereas if the powers of the base is there, see, a power b is there, that will come as the coefficient but in the denominator. Okay, 1 by b will come. So please note this down as well. So this is very important to solve the problems in derivative when you have to use logs to get the questions. Okay, so this is one of the property which is very important, and the second is this one where the questions comes a lot. When I say, I actually mean it. Okay, usually in KCET they'll not ask you direct easy problems of derivative. They'll ask you based upon these combinations only. Okay, this is clear. Let's move on. Now is parametric form. I'll take an example over here to explain to you. For example, if they ask you, they've given you y equals to, let's say, sine t, and they've given you x equals to, let's say, cos t square. Cos t square. What are they asking us? They're asking us to find, okay, simply dy by dx. Okay, all right. I'll keep the same variable, okay, 2 sine t square and cos t square, because it will become something, that's why. Okay, differentiate. So what happens over here, we end up differentiating dy by dt first and dx by dt first, okay, and then take the ratio. So we're gonna differentiate this first and then dx by dt also, then later take the ratio. To do it from here, you get dy by dt as 2 as a constant, sine becomes cos t square, derivative of 2t, what is t square derivative? Simply 2t. What's my answer? 4t cos t square. Again, same way do for this as well, dx by dt. What you'll have? You'll have a minus sine t square, and of course, chain rule for t square will give me what? 2t. Use it over here. So you have 4t cos t square divided by minus 2t sine t square. 4 with this is cancelled with 2, this t and t is cancelled. I get minus 2 cos by sine is what? Cot t square. That's my derivative. So what happens in parametric form? So both y and x will be given in the parameters, okay, and they'll ask you differentiating y with respect to x. So you have to differentiate y and x individually with the respect of their parameter t, okay, and then take the ratio to get the final result, okay. Sometimes they also do that, they'll give you a function, they'll ask you to differentiate a function with respect to another function. There also you're going to use same approach of parametric form. Do not worry, I'll take those questions when I'm solving the problems in 1 marker or 2, 3, 4, 5 markers, okay. So let's continue from here. Next and the last concept of the day will be second order derivative. As name, it is, you know, the definition of this is as simple as the name. Second order derivative, basically you differentiate it once, differentiate the derivative one more time, you get second order derivative, okay. So remember, we have the function given like this, let's say something y equal to fx. What we call dy by dx as f dash of x, correct. Differentiate this again, d by dx of dy by dx. What we get will end up with f double dash of x. This is called as second derivative. So you also usually write this as f double dash of x, or you write this as simply f of 2, or you write this as d square y upon dx square. The three different symbols to write the second derivative. What it basically means is, first differentiate it once and differentiate the derivative one more time. Differentiate the derivative one more time, okay. So derivative of the derivative, if it exists, is called as d square y upon dx square, and it is also called second derivative of y, okay. Is it clear? I have already written the notations over here, so please check. As I said, this concept is as simple as the name written on the screen. Second order derivative is what? Differentiating the first derivative is second order derivative, okay. But yeah, questions on this can be asked for 5 markers. Yes, so do not worry, when I come back and solve questions for all of you, you'll get to see all those problems. So this is clear, and this is the end of the session, the rapid revision for the chapter C and D. Oh my god, it was over quite in a very short amount of time, yeah, but I've not missed out on any topic. I have checked your NCERT and I've made sure that every single thing in your syllabus is covered. If I've missed something, what to do? Let me know in the comment section right now, and I'll take that into account and come back with another session to help you out in that. That's a promise. That is it for this session of rapid revision right now. I'll come back again in the 1 marker session, in the 2, 3, 4 marker session. Please attend that to solve questions on these concepts, okay. So with this I can end the session today. I'll see you again very soon in the next session. Till then, take care, bye bye.